Hello friends, today we are going to solve one example based on a chapter strain energy. So here we have a data, a 35 kg collar is released from height h to drop a disc at a bottom and C of a bar ABC, and A of the bar is fixed. Part AB is 2 meter long and 40 mm in diameter. Part BC is 1.5 meter long and 30 mm in diameter. Calculate height h for which maximum stress in the rod is 250 MPa. So whenever you are having a data, so try to draw a figure for that first. So first step is to draw a figure, and whatever the data you are having, that you need to write on your answer sheet. Okay, so the thing which is given to us, that is a 35 kg roller, and the weight is given, so this loading value is in kg, so mass is given to you, that is 35 kg. Okay, and it is released from the height h to drop at a disc. So we'll try to draw a figure. So what is given to us, that is this weight is released from height h and drop a disc at and C from the bar ABC, and A is fixed, and part AB is 2 meter long and 40 mm in diameter. So there is a variation in diameter in a two part AB and BC part, that is 40 mm in diameter, and BC part is 30 mm in diameter. Okay, so what will be your figure? Your figure is like this. This is your fixed portion, this is your okay, this is your AB portion, and which is 2 meter long. This is 2 meter long and 40 mm in diameter. This portion is 40 mm in diameter. Part BC is 1.5 meter long and 30 mm in diameter, and 30 mm in diameter. So this is 1.5 meter long, and diameter of this, that is 30 mm diameter. Okay, so a weight is fall from certain height. Okay, this weight is fall from height h. So this is your weight and this is your height h. This weight of this is 35 kg. Weight of this is 35 kg, and this end is C. So AB part and BC part. So calculate the height h for which the maximum stress in the rod is 250 MPa. So here you have also given that height you have to calculate, that is a question mark. Okay, and for which the maximum stress is induced in the rod is 250. So if you look at this figure, here 2 diameter is given. So what is given to you, that is stress is given to you, that is 250 MPa, but maximum stress. So you need to understand first in which portion, either in AB part or in the BC part, your maximum stress will generate. Okay, so that we'll see later on. So this is the question of which type of loading. So here in strain energy chapter we are dealing with three loads, that is your sudden load, gradual load and impact load. Okay, so this is the question of impact loading, where a load is fall from certain height. So whenever height is there in your question, h comes, so you need to understand that this is the question of your impact loading, and impact loading equations we have to use in solution of your question. Okay, so for a strain energy, some kind of energy is stored, so that we have to consider what is the equation of strain energy, work to be done and work to be stored. Whatever the work to be done on a body, that work done is to be directly stored on a body. Okay, so whatever the work done is equals to your work to be stored. So we know the equation of your impact loading, strain energy equations. So if we try to solve this question, we have to calculate your height h. So from the given data we'll start that, see, since this two bars in series, okay, and load on each bar is will be equal, so we'll consider that P1 equals to P2. P1 equals to P2. Now what is P? P is a load, but we have given a that load is in Newton or in kilonewton, but we have a load that is in a kg, so we have to convert it. So we already know that P is equals to mg, mass is 35 and g is your gravity, that is 9.81. so we'll get the value, that is 343.35 of your P value. Okay, this is the very easy thing. Now P1 equals to P2. If we consider that this 2 bar is in series and load on each bar will be same, for a when your bars in series, we'll consider that thing. So let us consider P1 equals to P2. So we know the formula, stress is equals to P by A. So we'll apply that thing. So here we have, let us consider this is your first portion and this is your second portion. AB is your first part and BC is your second part. Okay, so for this P1 equals to P2. Okay, so using this equation, stress in 1 and stress in 2. Okay, sigma 1 A1 plus sigma 2 A2. Okay, so sigma 1 is equals to A2 by A1 sigma 2. Okay, now what is the area of this? So you also need to calculate the area of this rectangle portion. Okay, so what is the area of that? You already know that area of your first portion, sorry, not a rectangle, it's a circular portion that having a value in diameter. Okay, so area of this first portion, that is 2 meter long, so pi by 4 d1 square, so pi by 4 into 40 square, so we'll get the value as a 1526.63 mm square, and this is pi by 4 d2 square, so second diameter is 30, so we'll get that value as a 706.85 mm square. Okay, so if you put this value in this formula, then sigma 1 is equals to 706.85 divided by 1256.63 sigma 2. So we'll get this value. Sigma 1 is equals to 0.562 sigma 2. This equation we will get because we don't have any option to calculate the value of h. Here also we had given that calculate the height h for which maximum stress in the rod is 250 MPa. Okay, so stress is given, but as the diameter is vary over here, so stress in both of this portion is change. But here the hint is given, so say they have written that maximum stress. So as you know that diameter of this portion is less, so chances of producing the stress in this portion is more. So we can write that maximum stress will occur in lower part, that is BC, as diameter is lower than the upper part. Okay, so what is given to you over here? The stress is given. So here this stress value is ultimately a stress 2 value, that is 250 MPa. So if we put this value over here, then sigma 1 is equals to 0.562 into 250. So sigma 1 is equals to 140.5 Newton per mm square. This what the value of sigma 1, and sigma 2 is 250 Newton per mm square. So here we'll get this values, that is sigma 1 and sigma 2. Okay, what is our aim? H. So up to this calculation there is no h comes in picture, but this is the, as you know that this is the question of your impact loading. For an impact loading, strain energy equation is that work to be done, whatever the work to be done is equals to work stored, or you can say energy to be stored. So we had already derived an formula. So work to be done in the body for impact loading, that is PH plus delta L is equals to work to be stored means your strain energy. Remember that it is a strain energy. So that equation is sigma square by twice C into V. This is the formula of your strain energy, but we have over here a two portion, that is portion 1 and portion 2. So here sigma 1 square divided by twice C into V plus sigma 2 square divided by twice A into V. Why we need to write this? Because there is a variation in your diameter. Okay, so because of that reason only we have to add this second portion, or you can say divide this both part. Okay, otherwise your equation should be sigma square by twice C into V. Okay, so here, so if we neglect the delta L value, change in length value, because there is nothing is given related to that. So here we neglect this delta L value and put all other values what we are having. Okay, so after neglecting delta L, if you put all the values, so your P is this 343.35 343.35 into H you need to calculate is equals to sigma 1 square. So sigma 1 is 140.5. okay, so 140.5 whole square divided by 2 into E is, here it is not given in a question, but we have assumed that 2 into 10 raised to 5, this is the common value of your modulus of elasticity, into, now what is V? So V is a volume of first portion, so V is ultimately area into length, A into L. So area, that you know, area of this is 1256 into L is given, that is 2 meters, so 2000 mm we need to take, that is, so A into L. So area of first portion, that is 1256.63 into 2000. okay, this is of your first portion. Now plus, this is a very easy thing, sigma 2 is 250 is given, 2 into 10 raised to 5 into V is again area into length, so A2 is 706.85 into 1.5 meter long, so 1500, that is the value. okay, so 343.35 H is equals to, if we solve this, then 124030.95 plus 165 665.96. so if we solve this, H is equals to 289,696.91. so H we are getting 843.74 mm. So here in a question we have calculated H, that is 843.74 mm height. Here in our question what we have calculated, if your load 35 kg weight is fall from certain height, so that height we had calculated, but that is for the diameter of a 30 mm diameter. okay, so anyone can interchange this question because height is given and you need to calculate this load value. okay, you also need to calculate the diameter value. This type of question in strain energy chapter is very or you can say many more time asked in your examinations. So this is all about your first example of your strain energy, where you need to calculate your height, and this is the question of your impact loading. How you come to know that this is the question of impact loading? In impact loading question, height word is given to you, so that height in any portion is given to you in a question. So at that time you have to use the formula of your impact loading, that is PH plus delta L is equals to work to be stored, that is sigma square by twice A into V. If there is a variation in diameter, then only this equation comes in picture, this much equation. If there is a variation in diameter, okay, then you need to use the whole equation. So this is all about your first example of your strain energy. Thank you.